So we have discussed 3 examples of how to determine the direction of a vector product. Let's try to turn the vector product the other way around. Means by let's try to flip the order of the vectors, or in other words, we try to commute the vectors. So if you commute between A and B, then you become B cross A. So we commute between them. So now this is B cross A. Let's try to determine whether B cross A has what kind of direction. Again, align our right hand, the fingers of our right hand, in the direction of the first vector. The first vector should be pointing to the right, so I align my hand like this. Then my palm is facing that direction, right? My palm is facing here, and yes, my vector is indeed on that side. I'm doing fine. Next thing, I try to swing my fingers to see whether they are able to swing from the first vector towards the second vector. First vector is B, second vector is A. So I swing from the first vector to the second vector, check whether I can do it or not. So first vector, swing towards second vector, no problem. Okay, if we position our hand wrongly, right, we can't really swing to A. That's not the natural way of swinging from B to A. This is much natural of ways of bending our fingers so that we can go from B to A. So once we check that it's correct, the position of our thumb will indicate the direction of the vector product, and the direction of our vector product is pointing out of the page, So here you can see B cross A is pointing out of the page. Okay, so what am I trying to show here is if we commute the vector, right, even though the vector will have the same, the vector product will have the same magnitude, but as you see here, if you commute, you have opposite direction. Okay, and since you have opposite direction, this and this are not equal anymore. So we can say A cross B does not have the same answer as B cross A. So in this case, we say that vector product does not obey because it's not equal, right? If it's equal, then it obeys. But now it's not equal, so it does not obey the commutative rule. Okay, so once we are done with that, let's check the other 2 examples we have here. Let's say today we do G cross F. Remember the vector sign, G cross F. So I'm going to do it in express way. So first align your hand, so fingers pointing this way, your palm is facing the second vector. Try to swing your hand whether you are able to swing from G to F smoothly. Yes, if you go that way, you can't swing smoothly. That's not the natural way. This is the natural way of swinging from G to F, G to F. Okay, once you are done, it's correct. So your position, the direction of your thumb will be the direction of the vector product. So this is pointing out of the page. Okay, last example here. Let's say if you are doing N cross M, N will be, we need to position our fingers in the direction of N first. So if we position like this, is it correct or not? No, because our palm will be facing that way. We want our palm to face the second vector. So we should flip it like this. Okay, do I have a better way of positioning my hand? Like this. Okay, so my fingers is aligned with the first vector and my palm here is facing the second vector. Now I try to swing from the first vector towards the second vector. Can I swing smoothly? Yes, I can swing from N to M smoothly. So that's the correct positioning of hand. So now my thumb is pointing into the page. My thumb is going into the page. So the direction of n cross m will be pointing into the page. So as you can see, when I commute between the two vectors, when I commute the vectors, I will get opposite direction. I will get opposite direction, I will get opposite direction. So this tells us that it does not obey the commutative rule. In fact, you can actually say that since the magnitude will be the same, right? You can say A cross B will be equals to the negative of B cross A, because it's the exact magnitude, just opposite direction. So this negative sign here actually indicates opposite direction. Okay, so just a thing that I mentioned but I forgot to add on. You can say that the magnitude of A cross B is the same as B cross A. This is the first thing that you know from earlier. Then the second thing you know is if you commute the vector, you get opposite direction. Therefore, you can end up with this conclusion that if you commute the vectors, you will get the same magnitude, but because it's opposite direction, there's a negative sign in front. So that's how we understand what will change if we commute the vectors.